Good day, everyone. I am Benedict P. Emnas III, a fifth-year engineering student from Xavier University, Ateneo de Cagayan. In this video, we will be discussing about mercury vapor lamps. First of all, let's know what mercury vapor lamp is. The mercury vapor lamp is a high-intensity discharge lamp. It uses an arc through vaporized mercury in a high-pressure tube to create very bright light directly from its own arc. This is different from fluorescents, which use the mercury vapor arc to create a weaker light that mainly creates UV light to excite the phosphors. Before there were metal halide lamps, there was the mercury vapor lamp. In fact, the mercury vapor lamp is considered the first type of HID or high intensity discharge lamp ever created. This time, we will talk about history of mercury vapor lamps. Many inventors worked to improve incandescent lamps during the 1890s, but only a few tried to develop practical discharge lamps. Unlike incandescent lamps that make light by heating the filament until it glows, discharge lamps make light by passing an electrical current through a gas. The current energizes the gas which then emits light. One inventor, Peter Cooper Hewitt, achieved success with a discharge lamp using mercury. Hewitt experimented with mercury-filled tubes in the late 1890s, and they found emitted an unappealing bluish-green light. The amount of light given off, however, was startling. In 1902, the Cooper-Hewitt Vapor Lamp Company, backed by George Westinghouse, was established to make the lamps. Though few people would want his lamps in their house, Hewitt realized that the poor color would not matter for others' uses. Ultimately, Cooper-Hewitt lamps proved cumbersome. A heavy ballast was needed to control the electric current, and each lamp contained nearly 1 pound of mercury. Starting early models required the user to tip the entire fixture over so that the mercury would run from one end to the other. Tungsten filament incandescent lamps made in the 1910s provided almost as much energy efficient as Cooper heavy tubes and gave a much better color. General Electric bought the Cooper Hewitt Company in 1919 and in 1933 began marketing a more convenient mercury lamp, the H1. So what are the key features of mercury vapor lamps? Let's find out. Mercury vapor lamps are bright, long-lasting light sources that are often used to light large areas. The bulbs have an inner quartz tube containing the mercury vapor discharge. Depending on the application, mercury vapor bulbs are sometimes coated with phosphor for color improvement or left clear. Also, mercury vapor bulbs with quartz envelopes had been used in germicidal applications because the bulbs allow ultraviolet light to pass. This time, let us discover the components of a mercury vapor lamp and its working. It consists of two electrodes made up an alloy of tungsten which is placed together in a medium containing mercury vapor and 25 to 50 torr of pure argon gas. These electrodes are enclosed in an elliptically shaped glass tube made up of silica. The external circuit connections from the bulb are given from the following components. As we can see in the illustration, a ballast component is similar to a transformer with high leakage reactance. It consists of four connecting ports like COM, 240 volts, 200 volts, and ignition. Also, it composed of an ignition which consists of three ports like red, yellow, and black. It consists of two polarity pins for connection, and the main purpose of the ballast and the igniter is to control voltage and current. So, the ballast port connection is made as follows. The black terminal of an igniter is connected to the neutral phase and also to the other terminal of the lamp. And COM port is connected to one terminal of the lamp. 240 volts port is connected to the 200 volts phase directly. 200 volts of ballast is connected to the yellow port of igniter, and the IGN port is connected to the red port of igniter. This is the explanation of the working of mercury vapor lamp, or in simple words, the operations. The mercury vapor and neon gas, pink in color, present in the bulb requires high voltage at the starting to illuminate light. When high voltage is applied, we can observe that the neon gas, which was originally in pink color, will change into orange color by heating. It is similar to a 100-watt glowing bulb, and it takes 5 to 7 minutes to turn on completely. The igniter, which is present internally, consists of a bimetallic strip and capacitor which provides high starting voltage. When the bimetallic strip expands on heating, it will short circuit, then the lamp will be turned on. When this bimetallic strip cools, it disconnects the connection and turns off the lamp. Hence, by connecting the ballast and igniter to this lamp, the mercury vapor and neon gas get heated up and expands, but the bulb inside to illuminate the light. There are two types of mercury vapor light bulbs being sold. First is the T-type. T-type light bulbs have a self-extinguish feature that shuts off the light within 15 minutes after the outer bulb is broken. Second is the R-type. R-type light bulbs do not have self-extinguish feature. They should only be installed in light fixtures that are fully enclosed by a lens of glass or plastic, or used only in areas where people will not be exposed to UV radiation if the outer bulb breaks. So, how much does it cost to run a mercury vapor light? Let's see. Your existing 175-watt mercury bulb uses the electricity it is rated at 175 watts. Add in the electric used by the ballast, etc., and the total is probably 200 watts. Running 200 watts for 5 hours is equivalent to 1000 watts for 1 hour, or 1 kilowatt per hour. Your electric probably costs about 10 cents per kilowatt hour. For the last part, let's see the pros and cons of mercury vapor lamps. Let's start with the pros. First is the energy efficiency. When compared to some fluorescent options, mercury vapor lamps use less energy and have greater luminous efficacies. Second is the bright white light. Mercury vapor lamps are highly regarded for their ability to produce a very clean white light. Third is the long lamp life. Mercury vapor lamps will last for at least 24,000 hours, with many lasting even longer. And now, we will look at the cons. First is the blue-green light. Due to the light it emits, it can sometimes have a very blue-green tinge. This has ultimately made these types of lamps not a great option for retail applications and in other indoor uses, as they can cause human skin color to look very off. Second is the warm-up. A rather lengthy warm-up time is required for mercury vapor lamps of anywhere from 4 to 7 minutes. Third is the mercury issues. Like with the other lighting options, the fact that mercury vapor lamps contain mercury has caused quite a concern for end users. Because of this, they cannot be disposed of easily. And lastly, UV radiation. Another cause for concern is the fact that mercury vapor lamps emit UV radiations. If the outer bulb was to break and the inner arc tube kept emitting light, the amount of UV radiation could potentially cause serious health risks for those exposed to it. In conclusion, mercury vapor lamps are the oldest high-intensity discharge lamps in existence, although they are rapidly becoming outmoded by high-pressure sodium, metal halide, and fluorescent lamps. Despite their drop in popularity, however, these lamps are one of the most dependable forms of both indoor and outdoor lighting. Some mercury vapor lamps have been known for the last 40 years. So, that's all for this topic.